All right, section 11.7, we're going to look at equations of circles. So this is what a circle looks like. We're just going to do only two warm-up problems real quick. So this is going back to the beginning of chapter 10. If CB is tangent to angle A, that means we know that the radius and the tangent make a 90-degree angle, which means because it is a 90-degree angle, we can use Pythagorean theorem to help us find the length of segment AB. So hypotenuse is across from the 90-degree angle, so 25 squared equals leg squared plus leg squared. So that is, say 25 squared is 625, and 20 squared is 400. So I'm going to subtract 400 from both sides. We get 225 equals x squared. 225 is a perfect square, so we're going to square root both sides, and the square root of 225 is 15. So we get x equals 15. I think this is section 11.4, but both of these are tangent. They meet at the same point outside the circle, therefore they are congruent. If they're congruent, that means we can set them equal. So let's set them equal and then solve this equation for x. I'm moving all my x terms to the left side, so we get 2x minus 3 equals 5. I'm going to put all my constants on the right side, so I'm going to add 3. We get 2x equals 8. Divide both sides by 2, and we get x equals 4. All right, so those were just two warm-up problems. I'm not going to do the third one. I think I'm going to delete this off of your notes so you don't have to worry about it. So, formula for a circle at the origin. Here's the formula for a circle. X squared plus y squared equals r squared, where r is the length of the radius. Okay, origin means 0, 0. So this equation right here, x squared plus y squared, has an origin or a center at 0, 0. So here you can see the center of this circle is at 0, 0. Therefore, I can write x squared plus y squared equals, now we got to find the radius and square it. So my radius is the length from the center to an endpoint on the circle. So that's 1, 2, 3, 4 units long. So I'll just say r equals 4. So we're going to square the radius to get 16. Notice I'm squaring it. It's not multiplying it by 2. So again, same thing here. Center is at 0, 0. That's the origin. So I can just write x squared plus y squared equals. And then we need to take our radius squared. Well, what is our radius? 1, 2. Okay, radius is 2 units long, so that's 2. So the equation of this circle is x squared plus y squared equals 4. Over here, center's at the origin. So I can do x squared plus y squared equals my radius squared. Well, what is my radius? 1, 2, 3. R equals 3. So put in a 3 for r. So we have to square it, and we get x squared plus y squared equals 9. All right, now that's only if the center of your circle is at the origin 0, 0. Now what if it's not at 0, 0? What if I move it left, right, up, or down? Now here's the new equation. X minus h quantity squared plus y minus k quantity squared equals r squared. Okay, so notice the difference. This minus h and minus k are new. The center is actually at positive h and positive k. So to notice, this is minus h, this is positive h. This is minus k, this is positive k. So the center is going to be at whatever the opposite of these numbers are. Okay, I'll show you what I mean by that in a second. This is always going to be a plus here, just so you guys know. Is the center point, and r is the radius. So the r didn't change. So now if you look at this circle, it has a center at 2, -1. So the equation is x minus h quantity squared plus y minus k quantity squared equals my radius squared. So my center is at h comma k. Okay. So if the equation is minus h, then I need to write minus 2 here. So notice this is positive 2, so my equation is minus 2. Okay. I need to subtract k, so subtract a -1. So really that is +1. So if you guys notice, it's always the opposite. So k is -1, so this should say +1. And then my radius, oh, well, you got to find the radius from the picture. My radius is 1, 2, 3 units long, so 3 squared. So if we simplify that, we get x minus 2 quantity squared plus y plus 1 quantity squared equals 9. And that's the equation of this circle. So again, notice this is x, the center is at +2, so this is -2. Notice this is -1, so this is +1. All right, this center is at 3, 2, right here. So let's write the equation of this circle. Is that what this is asking us to do? Let me see. All right, I think this is just an example. You can see the center is at 3, 2. The radius is 1, 2, 3, 4 units long. Okay, so if I am given the center and the radius, how do I graph that? Oh, I see what happened. I need to go in and delete these circles. Hang on. Okay, there we go. Sorry about that. So here, I'm going to graph the center at 3, 2. Remember, the x comes first. Positive x, we go to the right. Positive y, we go up. So 3, 2. My radius is 4. So we're going to go up, down, left, and right 4 units. So up, 1, 2, 3, 4 units. To the right, 4 units. 1, 2, 3, 4. Down 4 units. 1, 2, 3, 4. And to the left, 4 units. 1, 2, 3, 4. And then we're going to make a circle. It's kind of hard to draw circles. The only thing I don't want you to do is make it a box like this. That is not a circle, right? So just try to make it as neat as you can. Obviously, my circle was really bad, so I'm going to cheat and use the circle tool to make a nice, pretty circle. There we go. So you're going to make a point at the center, -4, 5. So let's go to the left, 4, up, 5. That's right here. And then radius, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then you're going to make a beautiful circle. All right, I'm going to cheat and use the circle tool. You just don't want to make a square, okay? So there we go. There's our circle. Center, 0, 4. So 0 in the x direction, up 4 in the y direction. Radius is 5, so let's go to the right 5, up 5, to the left 5, and down 5. And then let's draw a beautiful circle. And there we go. So that circle is at center at 0, negative. Oh, Miss Kinsel! That is not at 0, -4. Let's back that up. I went up +4. See, that's what happens when you're trying to rush. You make mistakes. 0, -4. Sorry. All right, to the right 5, up 5, to the left 5, and down 5. All right, now let's try that again. All right, how's that look? That's much better. 0, -4, radius of 5. All right, center, +3, so to the right 3, down 6, -6. So 1, 2, 3, 4, 6. There we go. There's my center, radius of 2. So right 2, up 2, left 2, down 2. Just magic. It just magically appears. Pretty cool. Center is at 0, 0. Radius is 7. So we go to the right 7, up 7, left 7, down 7, and we draw a beautiful circle. So again, here's standard form of a circle with center at +h, +k. So again, remember it's always the opposite sign. So now let's work on graphing these circles. So where's my center at? This says -2, so my center is at +2. This says +4, so my center is at -4. So to the right 2, down 4. And then Remember, this equals radius squared. So what times what gives me 9? If you're unsure, you can just take the square root of 9, and that means the radius is 3. So don't forget that it's r squared, so you have to take the square root of it to get r. So we're going to go to the right 3, up 3, to the left 3, and down 3. And there's my circle. Okay, again, don't have to be perfect, but just make sure it doesn't look like a square. All right, now we're not adding or subtracting anything to the x here, which means the x coordinate of the center is just at 0. Right? And then since this says minus 3, this is going to be positive 3 for the center. So 0 in the x direction, up 3 in the y direction. My radius, well, what times what is 25? If you're unsure, just take the square root of 25, and that's 5. So my radius is 5. Because remember, this is radius squared. So 5 times 5 gives me 25. So go to the right 5, up 5, to the left 5, and down 5. And we can make a beautiful circle. There we go. Next one. We're not adding or subtracting anything from y here. So this is going back to the beginning of the notes where my center is just at the origin. Right, 0, 0. And then remember, this is r squared. So the square root of 36 means that the radius is 6. So 0, 0. Let's go to the right 6. Let's go up 6. Let's go to the left 6. And then let's go down 6. And make a beautiful circle. Very nice. Wow, we got quite a few left. All right, I'm gonna zoom through these. All right, so this is +1, so the center's at -1. This is -5, so the center's at +5. So -1 up 5. This is 16, so if I take the square root of 16, that means my radius is 4. So let's go right, left, up, and down 4. There we go, and we can make a nice circle. Beautiful. All right, next one. -2, so my center is at +2. I'm not adding or subtracting anything from the y, so that's 0. So 2, 0, 2 in the x direction, 0 in the y direction. And then 64, well, what times what gives you 64? You could figure out what the square root of 64 is, and it's 8. So my radius is 8. So let's go to the left 8, to the right 8, up 8, and down 8. And that's a nice big circle, since it has a bigger radius. There we go. All right, this is +4, and this is +4, which means my center is at -4, -4. And what times what is 1? That's just 1, right? The square root of 1 is 1. So my radius is 1. So -4 in the x direction means left 4. -4 in the y direction means down 4. Radius of 1 is going to be a pretty small circle here. And there's my circle. Again, doesn't have to be perfect, just it shouldn't look like a box though. Last graphing one. I'm not adding anything to the x or the y, so my center is at 0, 0. Okay, for the radius, what times what is 9, right? What is the square root of 9? It's 3. So that's my radius. We're going to go left 3, up 3, right 3, down 3. And we can make a beautiful circle out of that. There we go. I could make that a little bigger. There, that looks better. Oh, mine was pretty off. That's much better. All right, so now the last part of this lesson, write the standard form of a circle whose center has the coordinates -4, -6, and has a radius of 5 units. So remember, here's the standard form of a circle. All right, this is H, this is K, and this is R. So let's plug those in. So h is -4, so we want to write x plus 4 quantity squared. K is -6, so we want to write y plus 6 quantity squared. And then my radius is 5, so 5 squared is 25. Don't forget to square your radius. All right, we're not adding anything to x, so we can just write x squared. And then since this is +2 for k, we need to do y minus 2 quantity squared. And then my r value is 9, so we need to square that because in my equation it's got to be r squared. So 9 squared is 81. And here's the equation of this circle. Here's h, here's k, here's r. So again, x, oop, that is not an x. X plus 4 quantity squared plus, that's a +5, so y minus 5 quantity squared equals, well, if r is 7, we got to square it. R squared is 49. And that's it for this lesson. I'm not going to go through your homework. Your homework is pretty similar to, I'll look at it. It's pretty similar to the notes. If you can't print this out, just do your best to make graphs on your piece of notebook paper. So, which of the following is an equation of a circle with center at the origin? So that would just be x squared plus y squared and radius r. Done. That one's C. Which of the following is an equation with center at 1, 1? So it should be -1, -1. So that has to be D, right? -1, -1. Match the equation with a graph. Notice 3, 4, 5, you're going to match A, B, and C. Find the center, find the radius, and you can match them. Here, you give the radius and the coordinates of the center. Yep, so just write center, center, like 0, 0. Radius here is 1. And then the equation would be x squared plus y squared equals 1. Give the radius and coordinates of the center of the circle. So all of these have a, whoa. Those are all the same. Okay, that's really odd. Okay, you only have to do one of them. Those should not all be the same. That's weird. And then, yeah, you're going to graph some circles. Again, try your best to make it on your piece of paper if you're not able to print this. And then the last 3 examples we did are just like these 4 here, where you're going to write the equation. As always, let me know if you need any help.